equations, part 2. So the purpose is to solve exponential equations which require logarithm application. Okay? So the idea is very simple. If you have two exponential expressions which are equal, then taking log of both expressions maintains the equality. So let's say m and n are exponential expressions, okay? And they're equal. So if I take logarithm of the left side and logarithm of the right side, with any logarithm to any base, then this equation will be equivalent to this equation, okay? Of course, we have to remember that n has to be greater than 0, and a has to be greater than 0, and so on. So in this course, we are going to apply only common logarithm, but generally it works anyways, whatever the base is. So to solve, this is the guidelines of what to do. To solve an exponential equation algebraically, take the logarithm of both sides of the equation using the base of 10. That's what I was talking about, right? Remember that the logarithm with the base 10 is called common logarithm. So, and then use the power rule to the logarithm to simplify the equation and so on. So once you took the logarithm of both sides, then you work with the laws of logarithm until you are able to isolate the unknown, okay? What is important? The same thing like in the exponential equations. You remember I kept focusing on the idea that left and right side have to be the single exponential expression. Here's the same thing, always. So it has to be the single exponential expression on the left, single exponential expression on the right, and then you can take log of both of them, okay? So let's look at the example. This example on page 484 of the textbook. Okay, here, this one. As you can see, on the left, we have 2 to the power of x plus 1. And then we have 3 to the power of x plus minus 1. Those who attended yesterday's lesson, you can see that there is no way I can change the left side or the right side to make the expressions with the same base. No, there is nothing in common between 2 and 3. There is nothing and I can do in order to express them in a different way with the same base. So this is the case, or this is the occasion when we are going to use logarithm. As you can see, this is a single expression, and this is a single expression, right? So I can take the common logarithm of both sides. So this expression and this expression are so equivalent. So it maintains the equivalence, as we said, right? Take a logarithm, of course, with the same base, maintains the equivalence. Once you have got these expressions, you start thinking, okay, which laws are there in order to isolate the unknown, right? The unknown now is in the exponent. So what I can do is I can apply one of the laws and move this exponent to the front. When I do this here and there, I know that this exponent now is becoming an expression which is multiplied by log, right?
The message is the 2 is not a base, right?
The 2 is what?
Not a base.
The 2 is not the base. The base here is not written. And I kept telling you that at a point, the base will be dropped because as it is on the calculator, log without the base means base 10. Okay, so you have a button like this on the calculator, which means it's base 10, and it's called common logarithm. Okay, let's move on. So once you got this product here and this product here, this is like with sinusoidal functions. Keep log without approximating it till the very last step, because this is, especially with these functions, it will make a lot of difference. If you start approximating early, the answer will be very different. So you keep log until the very last step. So once I got these expressions, okay, what I can do, this is a product. So I can multiply x by log of 2 and 1 by log of 2. So I can distribute basically log 2 among those two terms, both on the left and on the right side, right? So I get this expression. Please, as I'm going through the solution, ask questions if you have. All right, so then, once I have done this, I see that some of the expressions contain the variable and some don't. So remember, those which do not have the variable, they are just constants, right? They're numbers. So let's, just like in any other equation, put the terms with the variables together and the terms without the variables together. So it means that I will move this here in this case, we move everything with x to the right side and everything without x to the left side. So this is what you got, okay? So once you got this, you can see that x is the common factor between the two expressions. So you can factor it out. So if you factor out x from both expressions, you will get logarithm of 3 minus common logarithm of 2. Now, you're almost there. Remember, the target is to isolate x, right? You want x to be alone. So what now is left? To remove the coefficient, like all of this is the coefficient of x. It's a number, right? It's just a long number, but it's a number. So it means that I just need to divide by it, right? So I divide both expressions by this coefficient. And this is the last step. That's why all of this will go on to the calculator, okay? So you did not approximate log before that, right? Because if you did, then the answer would have been very different. So this is your final solution. Yeah.
I don't understand the part where like it's x log 3 minus x log 2.
Mm-hmm.
And then
X log 3 minus x log 2. This one.
You factor out the x.
You have to factor out, yes, because this is x times, right? It's a product. So it's a factoring, actually, strategy, which is in particular greatest common factor. Okay? You got it, Noor?
Yes.
Okay, great. So that's it. I believe it's so simple. And we're going to now work together on a similar question. The question is on page 512, question 6. 512, question 6. This is the one. Okay? There are very few questions like this actually in the textbook, so I found the one for you. I will add later on extra things from resources. So let's look at question 6, page 512. All right. So solve round your answers to 3 decimal places. So tell me, the first question which you should always ask is single or not? Is the answer to this question yes or no? Yes.
Yes.
Both expressions on the left side and right side are single. That means that what is going to be the next step? Not adding, taking logarithm of, right? Because we take logarithm of something. So we are taking logarithm of both sides, and in particular, common logarithm. So in this course, we will always use common logarithm, which means that the base 10, common logarithm with the base 10, common. It's called common because it's used most commonly used in science. Okay, so common logarithm. So let's write it. So when you write it, please put parentheses so that you are not making mistakes here. So it's logarithm of 6 to the power of x plus 1. Okay, next step. So the exponent can be placed in the front as a product with the logarithm expression, right? So it's going to be x plus 2. This is very important. Here, the parentheses are crucial. Okay, crucial, because then you forget to distribute. So x plus 2 times, Yusuf, what's left from the log, from common logarithm? When you took this one to the front, what's left? So common logarithm of 5. Now we do the same on the right side. So x plus 1 inside the parentheses, please, times common logarithm of 6. Next step, Noor.
You begin to expand.
So you distribute basically the common logarithm of 5, right? Here, and here the common logarithm of 6. Okay, so we're going to write x times common logarithm of 5 plus 2 times common logarithm of 5, and then x times common logarithm of 6 plus common logarithm of 6. Next step, Yusuf.
Put the axis on one side and the unknown on the left.
So the terms with x on one side, let it be left side. So x common logarithm of 5 minus x common logarithm of 6. And this one goes to the other side. So it's going to be common logarithm of 6 minus 2 common logarithm of 5. Okay, Omar is saying next step.
Oh, Miss, we can rewrite it as logarithm of 5 to the power of 2?
We can, but there is no need. You will just waste time.
Oh, okay.
Okay? So tell me what's the next step, Omar?
Miss, do we,
Do we what, Omar?
I'm thinking this one.
Unless you factor out the x.
Factor out the x to isolate.
Yeah, you factor x out.
Okay.
So when you factor x out, Omar, what's left in the brackets?
Log 5 minus log 6.
Yeah.
And then you divide on both sides, right?
Yeah.
Okay, I understand.
So log of 6 minus 2 log of 5, right? So last step, just divide both sides by the coefficient of x, which is this one. Right? So you see, Omar, that there's no point of doing this, right? Rewriting extra steps.
Oh, we don't need to do it.
No. So this is what you do. You put the entire fraction on the calculator, and then you provide the answer. Following this, round your answer to 3 decimal places. So please tell me the final answer.
7.827.
11?
No, 7.827.
27.
Mariam says 7, right? Okay,
Yeah.
Mariam, 7 point what?
827.
827. Okay, just a second. I will check the answer in the textbook. I'll check the answer in the textbook. 500, I said, and 12, right?
She might forgot to put the 2.
Maybe. Did you put 2, Mariam?
Yes, I did.
Because Yusuf got very different answer.
It's correct, yeah, miss. I did the same thing.
Question 6. So the right answer is 7.8. I don't know why they put 5. Okay. So this is the right answer, the one which Mariam provided. Let me stop now.